Happy Monday, everybody. Let's take a look at your Lesson 3 worksheet from Friday's class. And I'm sorry I'm not there to help you with your questions, but what I would like to do is give you a few minutes to get help from your classmates and help from Ms. Peters. So take out, hopefully you've circled the ones that you have problems with. The answers are on the back of your worksheet if you were not aware. So check your answers over. Anything you're having trouble with, see if someone in the classroom can help you. And after about 5 minutes, we'll come back to the video and finish off Lesson 3 examples. Welcome back, everybody. So this is at the very end of our Lesson 3 examples. And it's just another application type of question. We've done these questions before where you have to find the shaded area. And now what we're going to do is take it one step further. Once we get our answer, then we are going to take our answer and we'll write it in factored form. So this one leads us through our process a little bit. So the very first thing we're looking at is finding the area of the large rectangle. So we're looking at this, the full rectangle. And all we have to do is length times width. So 4x times 12x is equal to 48x squared. And the small rectangle, the one that is in the center, that white rectangle, the length times the width is 24. And now the shaded area, here's where the strategy comes in. If I want just the pink area, I'm going to take this full rectangle and subtract the part that we don't want to include in our area. So this is what it would look like. I'll take the large rectangle and subtract that small white rectangle, and that would be my expression for area. So we've done that part before, but what's new is the factored form. So we're going to be looking for a common factor. So the biggest number that divides into 48 and 24 is 24. And then the other factor, I would need a 2x squared, subtract 1. And remember that little strategy of checking your answer using distribution. So I check and I distribute onto the first term, and that would give me the 48x squared. I distribute onto the second term, that would give me the negative 24. All right, we've got one more like this in our notes, and this is going to be your practice question. And I will just give you the heads up. It is a little trickier than the one that we just did, partly because it's a circle. So let's make sure we know how to get the area of a circle. So area of a circle is equal to pi r squared. So I want to see how far we get with this one. And you guys, do not turn pi into 3.14. Use the pi symbol in your work. So we'll pause here for about no more than 5 minutes and see how far we can get on this one. Good luck. All right, my strategy for this one to find the area of that shaded region, the pink area I'll call it, is to take the area of the circle and subtract the area of the square. So let's get some formulas going here. For the circle, it's pi r squared. And for the square, there's a lot of ways we could do this. We could say base times height. We could say side squared, whatever you like to put here. And now my substitution. Pi, and it says the radius is 9x. And for the square, 3x times 3x. So what I need to do here is I'm going to expand it out so it would be just how we used to answer these questions. So I have to square everything that is in this bracket. So I'm going to get an 81x squared. And then I've got to multiply by that pi. But we're going to keep it written in terms of pi. So it'll be 81 pi x squared minus 9x squared. Now, before lesson 3, that's where we would have left our answer, but we want to get this in factored form. So I'm looking for a common factor. Well, both terms can be divided by 9x squared, and the other term would be 9 pi subtract 1. So, kind of curious to see how many people would have got that right. It was a little bit of a tricky one. All right, so what we're going to do before we get to lesson 4 is what we call an entrance question. So we'll do these throughout this unit. The entrance question is kind of just a checkpoint on the last lesson to make sure we're ready to move on. So Ms. Peters has a little piece of paper for you that you're going to do 2 entrance questions on. She'll hand them out to you, and then you can, when you're done, give them right back to her, and then we'll carry on with our lesson. So we'll pause here for a few minutes for you to do your entrance question. Okay, so you've finished your entrance question, you've handed in your work to Ms. Peters, and now we'll take a look at what you should have done. So number 1 is going to be worth 4 marks. You're getting 1 mark for figuring out the greatest common factor. So to do that, I look at the coefficients and I say to myself, what is the biggest number that I can divide from all of those coefficients? And I decide on 12. I look at the A's. I see A is common to everything, so A has to be part of our common factor. And I take the smallest A that I see, which is A squared. I do the same thing for B. B is in every term, so B is common. It has to be part of the common factor. And I take the smallest B that I see, which is just B. And then I use my distribution. I say, what would I have to multiply here to get the first term? And I end up with a 3AB. And what would I have to multiply by to get the 24A cubed B? What I need for that one is a 2A. And then my final step, I would need a negative B to make that term right there. So you have 4 possible marks for each one of those pieces. And same process here for number 2. So take a look at number 2. Because my first term is negative, the best way to do this factoring is to factor out a negative. So my common factor, I'll use a negative. And then remember to be very careful on your signs in the bracket. So when you distribute the negative, you do end up with the correct signs matching the original trinomial. Now, it isn't incorrect if you didn't pull out a negative. It's not as good, but if you did your work this way, you're still going to get full marks if you did it correctly. So there's really 2 ways that you could have factored number 2. All right, in your booklets for notes, let's find lesson 4, factoring a difference of squares. Now, we've done 1 day of factoring, but I want to make sure we understand what we do when we factor. So trying to get that terminology and that thinking in your head. To factor a polynomial means to write the polynomial as a product of factors. So in other words, we want to write a polynomial written as the pieces that would multiply to make that polynomial. And then it says, what factoring methods have you learned so far? Well, we will learn quite a few eventually, and you do have to know the names of them. So I want you to think about, what did we call the factoring that we did in lesson 3? And hopefully you said greatest common factor. All right, now to get ready for today's work, what we need to do is list the first 20 perfect squares. So I will get you to hit pause at this point, and I want you to write down as many as you can from memory, and then use your calculator to get the ones that you weren't sure of. So we'll hit pause here and give you a moment to write out your perfect squares. So most of those we've already got memorized from Unit 1. It would be good that we can recognize a few more than we needed back in Unit 1, because it will really be handy for us. All right, so before we get into factoring, now factoring, remember, is the backwards operation compared to expanding. So what we'll do first is we're going to expand, or in other words, we're going to do FOIL. But when we're doing this, I want you to be looking for patterns. This is one of those special products that we looked at a few days back. So go ahead, everybody, and give this a try. Ms. Peters, you can hit pause here and give them about 2 minutes to finish these ones off. So I've just got one more to go here. I'm going to go ahead with my FOIL steps here, doing the first times the first, outside times outside, inside times inside, and last times last. Now, the interesting thing about all of these polynomials is, because we've got opposite signs here and here, we end up with these opposite terms. And those two opposite terms are called zero pairs. Together they make 0. So it's almost like they cancel each other out. And all I have left is the x squared minus 25. So here's the patterns that we were looking for. First of all, how many terms do we have in all of our answers to those above? And every single time we get a binomial, there are 2 terms. And if you look carefully at all of our answers to those last 4, the sign in between the terms is always subtract. And then looking even more closely at it, if we look at every one of the terms, so the x squared, the 4, x squared again, 25, 4x squared, 1, 36a squared, and 49. What we see with all of those terms is that each term of the product is a perfect square. And that's why we call this a difference of squares. Because what we're looking at is this binomial, always a binomial. It's always a perfect square, subtract a perfect square, called a difference of squares. And what we have in the box here is the pattern that shows you how to do the factoring. So with variables, we get the general plan that would work for any numbers or variables. So if you take a look at the factors here, there's 2 factors. So I take this difference of squares, and when I factor it, I'll get a binomial times a binomial. I take the square root of this first term. So square root of x squared is x. That's going to go in the front of each bracket. Square root of y squared is y. That goes in the back of each bracket. And then always one of them will be subtract and one of them will be add. So let's give it a try. Ooh. I think you're going to find that this kind of factoring is actually pretty slick and pretty easy. First, though, we need to recognize that it's a difference of squares, because eventually our factoring is going to be mixed all together. We'll have 4 different kinds of factoring all happening in the same assignment, quiz, or exam. So we've got to recognize when to do what type of factoring. So when I see that I'm working with a binomial and it is subtract and it's a difference of squares, subtract a difference of squares, that's when I need to do difference of squares factoring. So part of it is recognition. Once I've recognized it, I set up 2 brackets. I'm going to take the square root of my first term. So square root of x squared is x. Square root of 9 is 3. We make one of them adding and one of them subtracting. And it doesn't matter which bracket you put your add in and which bracket you put your subtract in. Okay, let's try another one together. So again, I recognize it's a difference of squares. I set up the brackets. I take the square root of c squared, which is c. I take the square root of 49, which is 7. One bracket adding, one bracket subtracting. Go ahead and try c on your own. So I set my brackets up. Square root of x squared, that goes in the front of both brackets. Square root of 1, that goes in the back of both brackets. One bracket is add, one bracket is subtract. Now remember, if I ever wanted to do a check, it's not as easy as lesson 3 where we just had to distribute. If I want to do a check, I could check with FOIL. And when I FOIL this all out, what I'm looking for is to make sure that it comes out to that original polynomial. Okay, D has a fraction thrown in there, but it doesn't make it any tougher. We've got this definite plan that we follow. So square root of x goes in the front of both brackets. Square root of 4/9 is 2/3. That goes in the back of both brackets. One is add and one is subtract. Definitely a pattern, and we just have to follow that pattern. Okay, let's try E together. Setting up my brackets. Square root of 4a squared is 2a. That goes in the front of both brackets. Square root of 9b squared is 3b. Putting that in the back of both brackets. One is add and one is subtract. Please go ahead and try F by yourself. It looks more complicated, but it really isn't. If you know the pattern and the rules, you shouldn't have any trouble here. And then let's check your answer up here. So I take the square root of the first term, and that goes in the front of both brackets. So 6xy, 6xy. And now I do the same thing for the second term. So square root of 25z squared is 5z. That goes in the back of both brackets. One is adding, one is subtracting. And there are your factors. If we multiplied those out with FOIL, we would get the original polynomial. All right, let's take a look at G. G is one of these questions that people want to rearrange. You know, we've really learned well that our terms are supposed to be in descending order. So most people would say, hey, this is in the wrong order. It's supposed to be this order. However, if we write it in that order, it doesn't even look like a difference of squares. And there's a pretty good chance we're going to mess up our factoring. So we are not going to change the order of this. We're going to keep to our same old pattern. So I'm going to set up my brackets. Square root of 16 is 4. That goes first in each bracket. Square root of x squared is x. That would go in the back of each bracket. One is adding, one is subtracting, and we really do not worry about the order of those terms. So I'd like you to go ahead and try H and I. Ms. Peters, you could hit pause here and give them a few minutes to get these two done, please. And you can check your work up here. I just wanted to give you a little warning about J before you tried it. J is one of those ones that may not even appear to look like a difference of squares. I know I'm pretty good at knowing my perfect squares, so I do recognize the 4 and the 121 and the b squared and the a squared. I know that all of those are perfect squares, but it doesn't seem like it's a difference of squares. However, if we were to write it in this order, we would see that, oh yeah, it actually is a difference of squares. So you really have to be on the lookout for these. The better you know your perfect squares, the easier these will be to recognize. So once I get that order down, then I can go ahead with my factors. 11a in the front of both brackets, 2b in the back of both brackets. One is adding and one is subtracting. Now, K is another one that tends to fool some people once in a while because we are so good at picking out perfect squares. We see, oh, there's a perfect square. There's a perfect square, and we try to factor this, but it is adding, not subtracting. So this is actually a sum of squares. And it cannot be factored. If there was a common factor here that I could pull out, then I would be able to factor it, but there's no special factoring for a sum of squares. So we say this is prime. So don't be fooled by that one. And then L is an interesting one. Let's go ahead and start our factoring. So we see this a to the 4, and a to the 4 is a perfect square. Perhaps we should just discuss variables. Now, remember when you do the square root, let's say square root of n to the 6th. So remember, the number from denominator goes into notch. If we were doing that backwards, we'd say, oh, this is n to the power of 6 over 2, which is n cubed. So it is possible to do the square root of n to the 6th and have nothing left over. But if I try to do square root of n to the 5, well, it doesn't work out. There will always be a leftover piece. I can simplify it, but I can't actually do the full square root because the exponent here is odd and can't be divided by 2. So any variable with an even exponent is considered a perfect square. All right, let's try this one out. Setting up my brackets. So square root of a to the 4, all I do is divide that 4 by 2. It's going to be a squared. Square root of 81 is 9. 1 is adding, 1 is subtracting. And you might think to yourself, well, that's no different than all the other ones we've done. But take a look at that binomial right there, a squared minus 9, and hopefully you recognize, oh, that's a difference of squares. So you know what? This one is not completely factored because it could actually be factored further. So right here, we're looking at a difference of squares. And we can't leave it that way. We have to make sure it's fully factored. Now, this first bracket is a sum of squares. It cannot be factored. But the second one here in factored form would be a plus 3, a minus 3. And now it is completely factored. And we are ready to get to our practice work. But I want you to be on the lookout for this type that kind of goes into a second round. And the reason that it did that is because 81, when you take the square root of it, what you get is another perfect square, and that's why you have to watch out for that. Same thing with the a to the fourth. When I did the square root of it, I got a squared, which is a perfect square. So we've got to watch out for those ones where when you take the perfect square, you still get a perfect square. So let's think of some other numbers that could happen with. It could happen with 16, because square root of that is 4, which is a perfect square. We already saw this take place with 81. 625 is another one. 256, there's another one. Oh, here's a good one. The most common one is the number 1. So be on the lookout for those numbers. And here is your first assignment. So your answers are on the back of the sheet. Make sure that you check your answers as you go. And I'm going to suggest that every so often you check one with foil, because on a quiz or an exam, that's how you would be checking your answers. So let's say check with foil once in a while. Okay, so we're going to pause here for a little bit, and then let's see where we're at here. We'll give, I don't know what this will be, 10, maybe 15 minutes of work time. And when you feel like most people are done, or if we hit 15 minutes, then it's time to get back to the lesson. So 15 or less, please, Ms. Peters. Welcome back, everybody. In this next set of questions, what we're seeing is that a difference of squares may occur after a greatest common factor is removed. And this is a good time for us just to write a little note to ourselves. Always check for a greatest common factor before a difference of squares. So we're getting into the questions where you're going to have to do two kinds of factoring to get this completely factored. But you should always be doing a greatest common factor first. So if I look here at A, I gotta think back now to lesson 3. The greatest common factor for this one is going to be a 2. So I'm going to pull a 2 out. The other factor would be 4m squared minus n squared. Now in lesson 3, we did that and we said, okay, we're done. But we always need to look in the bracket to see, could that factor, that binomial that's in the bracket, could it be factored further? So looking closely here, what I recognize is that that is a difference of squares. And so I'm not done factoring until I have factored everything possible. So the 2 is still one of the factors. I can't just let it disappear. And that difference of squares, I can break it down to be 2m plus n, 2m minus n, and then I am completely done. So we really want to get in the habit of always looking at the brackets, always looking at those binomials to see, can they be factored further? So at this stage of the game, we should be looking for common factors in here, because maybe we missed one at the beginning. And then we should also be checking to see, is there another difference of squares in there? Let's try B together. So common factor here of 3a the other factor, a squared minus 4b squared. So remember with these guys, you do that little distribution to make sure that it works. So not only do we check to make sure it works, but we should also be checking to make sure that it is completely factored. And this one is not, because what we have here is a difference of squares. So I can't leave it this way. I need to get it completely factored. So I have my common factor of 3a. Set up your brackets for the difference of squares. So square root of a squared is a, that goes first in each bracket. Square root of 4b squared would be 4b in the back of each bracket. One is adding, one is subtracting. So factoring this one actually gives us 3 factors. We've got that factor, we've got another one here, and another one here. So 3 factors that multiply to equal the original binomial. All right, let's have you guys try C. And I'll just give you heads up on this guy. To watch carefully with what you get, I suppose, is the good thing to say here without giving too much away. So everybody's working on C, please. So I factor out a common factor of 2, leaving me with x to the 4th minus 4. And taking this farther, difference of squares, I need to break it up. So square root of x to the 4th, that's x squared. Square root of 4 is 2. One is adding, one is subtracting. Now, what I was saying earlier about look carefully is sometimes we see this x squared and we think, oh, there's a perfect square. This can go further. But remember that that's a perfect square, but this isn't. So this is fully factored. This is not a difference of squares. And that means we are done our factoring right there. Go ahead and try D, please. So common factor I can pull out is 8. And then x to the 4th minus 1 would be the other factor. But I am not done because look at that. There's a difference of squares right there. Have to keep going. So square root of x to the 4th is x squared. Square root of 1 is 1. One is add, one is subtract. Anybody notice that we are not done yet? There's a difference of squares in here still. So we have to keep going. The first 2 factors stay as they are. They're already in complete factored form. But this x squared minus 1 is a difference of squares. It becomes x plus 1 times x minus 1. And then we are now ready to do assignment number 2. So back to lesson 4 worksheet. Pick it up wherever you left off. But when you're done with that first assignment, then go ahead and work on number 69 to 80. And that's actually where we're going to stop for today. Let me just see. I had a couple announcements for you guys here, I think. Oh, yes. I've talked to some of the math teachers in our school. They are very willing to help you out if you have any questions or any problems that Ms. Peters can't help you with or that your friends can't help you with. So feel free to drop in at the math and science office. Just knock on the door and say, I'm in Mrs. Booth's class. Could somebody give me some math help? And there will be people there that would be happy to help you. And I guess that's it. So if hopefully there's some time left in class, you've got the rest of class to finish off your assignment. And we'll finish up here tomorrow. Have a great day. Stay strong and be kind, people.